So say types of semiconductors, you know that intrinsic semiconductor and extrinsic semiconductor. You classify into two types. One is intrinsic semiconductor, another one is the extrinsic semiconductor. Intrinsic semiconductor means it is the purest form of semiconductors. So semiconductors in its pure form, without any impurities, is called intrinsic semiconductor. What is meant by impurity? Suppose you are taking that silicon, it contains all the atoms in silicon. Suppose any other atom is mixed with the silicon, it is called impurity. So without any impurity, the pure form of element is called intrinsic semiconductor. So silicon is here. It has a outermost orbital. It has the 4 electron. In ordinary room temperature, what will happen? That covalent bond is broken and it produces the 1 electron. See here, 1 electron is produced. So this is 1 electron. The covalent bond is broken. So 1 electron is emitted from here. So that emitted electron is called a free electron. So here that the empty space is called hole. So the electron is a negative charge. That hole is taken as a positive charge. So it's called hole. Yeah, it's a positive charge only. That empty space is called here. It's a hole. It has positive charge. So this covalent bond is broken for the ordinary room temperature. So intrinsic semiconductor, the covalent bond is broken. The electrons are emitted. Here the charge carriers are produced. The free electrons and the holes. So it's called intrinsic semiconductor. The number of electrons are equal to the number of holes. So the total charge of the intrinsic semiconductor is neutral because the total number of holes and electrons are equal. At 0 degree, it behaves like a insulator. When temperature increases, the covalent bond is broken and that electrons and holes are produced. So it will become a conductor. So it has the dual nature, insulator as well as a conductor. So it is called semiconductor. It's a purest form of semiconductor. That's why it is called intrinsic semiconductor. So the intrinsic semiconductor, that another one thing is extrinsic semiconductor. Extrinsic semiconductor means that impurities is added to the intrinsic semiconductor is called extrinsic semiconductor. Impurities means that other atoms are added with the purest form of atoms is called extrinsic semiconductor. The process of adding impurities to the intrinsic semiconductor is called doping. So the process of adding impurities to the intrinsic semiconductor is called doping. So that method of adding the impurities is called doping. The material that which is used to doping the material is called dopants. So that impurities which is you are going to add at the pure atom is called dopants. So how much you are going to add the dopant means we have the measurement. The impurity atoms are called dopants and its order approximately 100 ppm. That 100 ppm means 100 parts per million. That is the measurement of adding the impurities to the pure atoms. So 100 ppm, part per million, parts per million. So it's called extrinsic semiconductor. Intrinsic semiconductor means it is a pure form of semiconductors. So there is no any extra element is mixed with the semiconductor. Extrinsic semiconductor means that impurities added to the intrinsic semiconductor is called extrinsic semiconductor. It contains impurities. So semiconductor materials. So what is the semiconductor? How it is exhibit the electrical conductivity. So the major classified into 2 categories. So here again we are going to see that in our animation process. So they are majorly classified into 2 categories. The categories are, so semiconductor is divided into 2 categories. One is intrinsic and extrinsic. That extrinsic semiconductor is again classified into N-type semiconductor and P-type semiconductor. So now you know that what is being the intrinsic semiconductor and extrinsic semiconductor. Intrinsic means pure, extrinsic means impure. Okay. So now we are going to take the pure form of semiconductors. For example, silicon and germanium. So it is mixed with the tetravalent. The tetravalent means you know that there is 4 atoms. The silicon and germanium have the tetravalent. So it has 4 electrons in the outermost orbital. See the picture is there. So silicon has the 4 electrons in that outermost orbital. That 4 electrons are mixed with that another one for silicon atoms. So this is the bonding of silicon. Silicon or germanium, the two things are same. You can take the example for silicon. So in tetravalent atom, see that here the covalent bond is broken. 1 electrons are emitted, then that 4 empty space is produced. That is gray color. The red color is the electron. The covalent bond is broken. That electrons are emitted. So here you see that energy valence band and conduction band is there. That the energy difference between the two bands are called the band gap. That is forbidden energy gap. Okay. So this is the energy gap of the silicon. Right. So after the covalent bond is broken, one electron is ejected, an empty space is created. That empty space is called holes. You know that, and the red color ball is called that is electron. So the electron is jumped from valence band to the conduction band. So it requires energy, right? So we give that energy means the electron can jump from the valence band to the conduction band. So in ordinary room temperature, that energy, the heat energy is absorbed by the electron, then it is jumped from the valence band to the conduction band. So the line indicates that jump from the valence band to the conduction band. So we have to give the energy to the electron. So continuously that covalent bond is broken means the large number of electrons are produced. The produced electrons are used for the conducting purpose. So it conducts the energy. So extrinsic semiconductors, there are impure form of semiconductor materials found by adding the pentavalent or trivalent impurities into a pure form of semiconductor. So pure form of semiconductor, you know that pentavalent. Pentavalent means it has the 4 electrons in the outermost orbital. Trivalent, it is 3 electrons in the outermost orbital. So extrinsic semiconductor is classified into 2 types, N-type and P-type. So N-type is made by adding the pentavalent element. The P-type formed when trivalent impurities are doped. So when the pentavalent is added to the pure atom, it will become a N-type. Trivalent is added to the extrinsic semiconductor, it will become a P-type. So using that pentavalent and trivalent atom, we can produce the N-type semiconductor and the P-type semiconductors. So now you can see that N-type extrinsic semiconductors, how to produce the N-type semiconductors. So pentavalent impurities atom like phosphorus, antimony, arsenic are the pentavalent element. So now we are going to use the phosphorus is doped with the silicon. You can take that phosphorus. Phosphorus is a pentavalent element. Silicon is a tetravalent element. That means silicon has 4 electrons, pentavalent has 5 electrons in the outermost orbital. So here it is the phosphorus is doped with that silicon. It's also known as donor impurity due to presence of extra free electrons. So extra free electrons, see that the round is indicating that extra free electrons. So it's called donor impurity. So when covalent bond is broken, 1 electron is ejected from that bond. So it has 1 empty space. That empty space is called hole. That is a 1 electron. That electron is used for the carry energy from one atom to another atom. So already 1 free electron is present in that. So now it has the 2 electrons. So the ordinary for silicon, it has only 1 free electron that comes from the breaking of that 1 covalent bond. Now it has the 2 free electrons. So what will happen? The donor energy level. See here, band gap is very large, but now we have the 2 energy. So the donor energy level is increases near to the conduction band. So the Fermi level is that, you know, the red color line, that red color line is increases very close to the conduction band because we have large number of charge carriers. So the when charge carriers increases, that lower donor level also increases. That is donor energy level. It's very close to the conduction band. That means it very small amount of energy is given to the electron. It can easily jump from the valence band to the conduction band. So it occurs in ordinary room temperature. No need to give the extra energy. Okay, more than that temperature. Now P-type. See that the trivalent impurity, boron, aluminum, cadmium, indium are the example for the trivalent. Now here you are going to use the boron is the trivalent. That is doped with the silica. It's also known as accepted impurity due to presence of extra hole. See, N type it has the extra electron. Now it has extra hole. See that the tetravalent silicon has the 4 electrons in the outermost orbital. Boron has the 3 electrons in the outermost orbital. So all the 3 side is shared with that electron with the silicon atom. That one side is has a empty space. So what will happen? It's called that empty space is called hole. Now what happened? That covalent bond is broken, one electron is emitted. So here that one hole is produced, that electron is jumped from that one hole to another hole. Here that holes are majority charge carriers compared to that electron. So electron is very small, but holes it has a large number of holes. That already available one hole, when covalent bond is broken, then another one holes is produced. So what happened here? Acceptor energy level is increased. See that line is very closer to the valence band. That means acceptor level. That means that holes are majority charge carriers, electrons are minority charge carriers. Again, we can when you give the very small amount of energy, that electron can jump from the valence band to the conduction band. So here also it's a very small amount of energy. It's called the P-type semiconductor. So initially that's a N-type semiconductor. N-type semiconductor means it contains large number of electrons. That is, you can remember that N means negative. It contains large number of electrons. P-type semiconductors, it has large number of holes. What is positive side? That is positive. Energy band. See that energy band, how it is increases. Now only we saw that thermally generated electron in the conduction band that created due to the release of an electron. It's very close to the valence band to the conduction band. So electron can easily jump from the valence band to the conduction band. So this is a N-type. So donor level is very close to the, so electron jump from the valence band to the conduction band. Again, you can see that animation of the N-type semiconductor material. So the same thing, again you can see that another one animation. A small amount of pentavalent impurity is added to the pure germanium semiconductors. That is called N-type. So pentavalent add பண்ணோம் அப்படின்னா என்ன எழுதுறோம் இது ஜெர்மனியம் இங்க வந்து பாத்தீங்க அப்படின்னா ஜெர்மனியம் எடுத்துருக்காங்க. So electrons are the because the tetravalent 4 atom is there. So arsenic is impurity is added to the germanium. So what happens? That one electron is extra. So already it has 4 electron. It is combined with the germanium. That one free electron is there. When covalent bond is broken, that another electron also produced from the covalent bond. That another electrons are there. So the large number of negative charge carriers are produced. So it contains large number of electrons. That electrons are used for the conduction. So it's called a N-type semiconductor. So electrons jump from valence band to the conduction band. So animation. Again, you can recall that how the positive charges are produced and the negative charges are produced. So N-type semiconductor, it has large number of electrons. So it's called N-type. So N-type semiconductor is this one. Next one is P-type. So P-type, again you can see the another one animation part, P-type semiconductor. So in small amount of trivalent impurities such as indium, boron, and gallium, it's a metal of indium, boron, and semiconductors. Just you recall that what is P-type semiconductor. So P-type means P positive. So it has large number of holes. So how boron only 3 electrons is issued the germanium. So it has one more hole. That boron bond is broken. That produces the another one phase. Like that, all the atoms are producing the large number of holes. So here, holes are majority charge carriers. That's why it's called the P-type. P means positive. Like that, we can see. So we adding that any trivalent, pentavalent, that N-type and P-type semiconductors are mutual. as we are talking neutral atoms to the intrinsic semiconductor. It's a neutral only. What is the amount of you are adding the pentavalent. See the extra energy is given to the atom. The holes are produced. See how the electrons are moved from one hole to another. So here it contains large number of holes. So acceptable. So energy gap is very small. First level is very close to the valence gap. Electron can easily come from valence band to the metal.